In this lesson, we are going to learn how to plot two-dimensional graph in MATLAB. So let's start with creating a script. So I've created a script called plot2d. Now to plot a graph in MATLAB, of course we need the values of x and y. So let's define our x value to have a range from 0 until 2 pi. So x is from 0 until 2 pi with an increment of pi over 100, and y is simply sine of x. So to plot the graph, the command that we need to type in is plot x, y. So when we hit run, this will plot a graph of x against y. So the value of x is from 0 until 2 pi, and the value of y is basically the sine of x. There are a few things that we can include in the graph. For example, the title of the axis. We can also put a title of the graph. We can include a legend, and so on, and this will be discussed in a short while. So now let's take a look at how do we change the color of the line. So if you type in the command window help plot, you will see instructions that MATLAB gives to plot a graph in MATLAB. And if you scroll down here, you can see that various line types, plot symbols, and colors may be obtained with this command. So we have a few colors that MATLAB understands. B for blue, G green, red is R, and so on. And for example here, if we include another syntax, comma, R for example, within an apostrophe, the color has to be written as a string. So this is our command. Now when we hit run, we will get a new line with red in color. That is how to change the color of the line in MATLAB. And we can also use other colors that MATLAB understands here. For example, magenta, yellow, and so on. So now we're going to stick with red first. And then let's take a look at this part here. If we do not include anything for the line type, the default setting will be solid line. If we include double dot, this will produce a dotted line. If we include dash dot, this will produce dash dot line. If we include two dashes, then the MATLAB will plot a dashed line. Let's include here, for example, double dot. So when we hit run, we will get a dotted line. If we do dash dot, when we hit run, we will get a dash dot line. And if we do only dash, we will get a straight line as usual. And we can do dash lines by typing two dashes. When we hit run, we will get dash lines. Okay. Next is the marker. So if you notice over here, MATLAB also understands a few commands to create marker. Now if we put on, if we type in O, and MATLAB will create a circle as a marker. Let's try that. We include O in the command. So when we hit run, then our line here, our graph here, will have a round symbol as a marker, a circle marker. We can change this to X mark by typing X. Now when we hit run, we will get X marker, and so on. There are a few more marker types that MATLAB understands. If we put D, for example, we should get a diamond marker. like this. Okay, if we zoom in, we will see that the marker is diamond. Yeah. So basically the plot command is, in general, you have to type in plot x comma y. That will plot x against y. And then we have what we call as a line specifier. This is what we have done so far by changing the color of the line to red, changing the type of line into dotted line, dashed lines, and so on. And after line specifier, we will there is another syntax that is called a property name. Property name also must be written as a string within apostrophe, and then we have property value. So I will explain what is property name and property value. So here, our command here so far is x, y, and we have line specifier. We specify the characteristics of the line. Now we put another comma. Let's say now we want to increase the line thickness. If I run this now, this is the thickness of the line that we have. Now the default unit for the line thickness is 0.5. So if we want to, let's say, increase the thickness of the line, we put another comma, and within strings, within apostrophe, we type in line width. Okay, we type in line width, and then we need the value. So now we put a value, let's say 5. The value must not be a string. The value is written as a number. So when we hit run, now we get a very thick line. Okay, that is how we change the line width. And also we can, let's say we have a marker. I'm going to decrease the number of increment here so that we will see the marker more clearly. See, that is the marker. And I'm going to change the line width to 2. Okay, we see now the marker is a circle. Now, if I want to increase the size of the marker, now we put another comma here, and within a strings, we type in marker size. Marker size, comma, let's say the default, so marker size, let's say we put 10. Now when we hit run, we will see the marker has been increased. Okay, that is the marker size. And we can also change the marker color. For example, we put comma within a string, marker edge color, comma, we put the color has to be defined as a string as well. So let's say now I want it to be blue, so I put in B. When I hit run, you see now the marker has changed to blue. And we can also put color inside the marker by typing the property name or the command marker face color. And also within the strings, let's say we want it to be yellow, so I put Y. Okay, when we hit run, we see that now the marker has yellow field inside, blue on the outer of the marker, because we set in marker edge color is blue and our marker face color is Y. Okay, so that is the property name and also property value. Okay, now let's take a look at how do we manipulate the axis. You can type in help axis to see how the command needs to be written. So MATLAB gives a few axis command that we can use. The normal one is axis to define the minimum and maximum value of the x-axis and also minimum and maximum value of y-axis. Let's try to do this first. So we're going to copy this, and let's say we want the x minimum to be 0, the maximum of x to be 6, the minimum of y is, let's say I put minus 10, and the maximum of y is 10. So when we hit run, now we'll see that our graph has a minimum value of 0 for x-axis, maximum value of 6, minimum value of y-axis is minus 10, maximum is 10. So we can of course change this according to our preferences. That's why we see that the graph is now a little bit less tall, because we have set the minimum and maximum value of y-axis to be very high. We can change, for example, if I put here minus 5 and also 5, yeah, you will get something like that. And what if we want to go back to the original axis that MATLAB has suggested? MATLAB will automatically calculate the axis for you, what should be the minimum and maximum value of x, and also minimum and maximum value of y. So in this case, we have the command axis auto that will use the automatic functions in MATLAB to automatically scale the axis for you. So if we do axis auto, we hit run, we will get what we have, like what we have previously. So this is the default axis. We can also do axis, for example, tight, that will set the axis limit to the range of the data only. There will be no extra on the minimum and maximum of both axes. So let's try that. Axis tight. When we hit run, you see that the graph is exactly from the beginning of the point until the end, and also for y-axis is the same. Okay. We can also try axis square, makes the current axis box in square size. Let's try that. Square, and yeah, now you see that the graph has become a square because the axis has been automatically adjusted to make sure that we have a square plot. So that is the function of axis square. So there are a few axis manipulation that you can refer by typing the command help axis. This is how you can see how to change the axis or to manipulate the axis. Just for now, we're going to stick with axis tight. Okay, this should be our axis tight. Now let's go to how do we put label on the x and y axis. Okay, so to put label of x-axis, the command is just simple. You just type in x label in a bracket. You type in text. You see MATLAB has given us a hint, x label txt. So we put within apostrophe, it has to be a string. So x label is, in our case, is x. For example, we put in x, like that. And we type in y label for the y. So y label is now sine of x. Okay, so when we hit run, we will see that x appear down here as the label of x, and sine of x appear here as the label of y. We can also include the title of the graph up here by typing in the command title. Also, we type in as a string, we can type in, this is a graph of sine of x, for example. So when we hit run, we will get a title here written in bold typeface, graph of sine x. Okay, then we can we can include a text in the graph. For example, we type in gtext by using gtext command. Let's say I type in here using gtext command, gtext. This is a text entered using gtext command. When I hit run, MATLAB asks us where do we want to place the text. So let's say I'm going to place it here. Then you see this is a text entered using gtext command. Okay, another command is by typing in the text command, that is gtext. We can also type in text command, text, and for text command we need the xy coordinate. So let's say we want it to appear at x equal to 4, comma y equals to, let's say, 0.8. Okay, and then we type in the text. This is a text entered using text command. So when we hit run, now for gtext command, it requires us to pick the location. So I'm going to pick here for gtext, and the text down here is appears because of this text command. So this is a text entered using text command. It appears at the exact location where we have defined it here according to the coordinates of x and y. Okay, and we can also include legend in the graph. So I'm gonna remove this first, or we just comment it. Okay, now to include a legend, we type in simply the command legend, and then we type in what we want to, the name of the curve. For example, here I want to type in sin x as the legend. It has to be also a string. When we hit run, we get sin x over here appears as the legend. Now we can also define, this is a default location of legend, and let's say you want to change the location. In MATLAB we can define the location by including after the name of the legend, we put a comma and we type in location. Okay, location, we want to change the location, and comma, then we need to know where to put this. So if we type in help legend, MATLAB will list the location of the legend. We can use these locations here. So there are north, south, east, west, northeast, and so on. But the best thing is that there is a best location. So MATLAB will automatically find the best location to put the legend. And also there is another command that is best outside. MATLAB will find the space outside the plot to put the legend. So let's take a look at a few example. If let's say we put north, so we get our legend to appear at the north. So if we put south, it will appear down here. So let's try south. Now the legend becomes down here, and you can try a few other things. For example, north outside, it will be outside of the plot near top. So let's try this. I'm going to copy this and put it here and hit run. And we see now the legend is outside of the graph, north outside. Of course, we can put it outside and bottom. That will be much better in my opinion. So this will be south outside down here. And as I've mentioned, there is the syntax best, which MATLAB will find the best location for the legend to appear, and MATLAB thinks that this is the best location for the legend to appear in our graph, in our current graph. Okay, that is about legend. And next is we can also include grid. by typing in grid on. So when we hit run, we get a grid. So if we don't want the grid, we can simply remove the command, and when we hit run, there will be no grid. Or we can also type in grid off, and when we hit run, there will also be no grid. So it's either you put grid on, or you just remove the grid command. So we'll just stick with a grid for now. Now let's see how can we plot a few graphs in one plot. So let's say, for example, we have these variables defined. We have x as the range from -2 until 4 with an increment of 0.01. Then we have y equals to 3x cubed minus 26x plus 6. yd is 9x squared minus 26, and ydd is 18x. So to plot all of this graph together in one plot, we use the same plot command. Now first we plot x against y. Then we define what is the line specification. Let's say we want this to have, for example, blue solid line. So we type in b dash or dash b. Either way, it's fine. Now we go to the second plot. Now we want to plot x against yd. So we type in x comma yd, comma again. Now we put specifier for this line. Let's say we want this to be red and dash line. So we type in arc with 2 dashes, and then we plot the last line, that is x against ydd. So x comma ydd, comma again, then the specifier for this line. Let's say we want this to have a dotted line, that is colon, double dot, and we want it to have a black color, so k double dot, and then we close the round bracket. When we hit run, we will get these 3 plots in one graph. So we can also include the property value like we have in the single plot. So we put in, in case we want to increase the line width, let's say we type in line width, and we put in the value, say 3. So this will increase all lines into 3. So when we hit run, we can see that the line width has increased for all 3 graphs. So that is the first method that you can use to plot a multiple graph in one single plot, in one figure. So the second method, this is the first method. Okay, now I'm gonna comment this and try to plot using the second method. The second method is using the command called hold on and hold off. So now let's plot the first graph. Say we plot this one first. So I will copy and paste here. So when I hit run, I will get this line. Okay, now if I, let's say, now put this command here, okay, if I hit run, I will not get the first line because it has been overwritten. MATLAB will plot the first graph, the first plot, and then when the second plot is executed, MATLAB will remove the first plot and only plot the second plot. So in order for us to plot the both graph by using individual commands like this, we need to include the hold on command. So we should type in between the plot command hold on. So when I hit run, now both plots appear. And then I include the last command, that is this one. So plot this one. Okay, now when I hit run, all three plots appear because the hold on is still there. So when I have finished with the hold on command, I should include the hold off command so that the next plotting will not be plotted on top of this tree graph. Okay, so this is the second method by using hold on and hold off command. So we plot the first graph, we put a hold on command, we plot the second and third graph, and then we put a hold off command. So when we run this, we'll see that all graphs appear in this single figure. So that is the second method. So let's go to the third method. I'm going to comment all of this so that it will not run. Okay. Now the third method is by using line command. Okay, so now let's say we plot the first one. We plot the first one. So when we want to plot the second line, the second graph, we don't use the plot command, but this time we use the line command. And line command, you type in x, yd now, and we cannot use the same line specifier syntax that we use in plot command, because in line command you have to type in line style. So we need to type in line style, comma, now we want it to have a dashed, so double dash, and then we want it to have color. We want it to have a color red, so we type in color, and then we type in R. So the command is slightly different from the plot command. Now when we hit run, we will get these two graphs like this. So it's a little bit confusing because the command is now different from what we have in plot command. But this is the third method that you can create multiple or plot multiple graph in one figure. So when we want to plot the next one, we use again line command. But by using line command, you don't need to use hold on and hold off. So now we want YDD. Line style is now colon, so that it will produce dashed lines, and we put color as K for black. When we hit run, we will get this this graph of 3 lines. So that is how we plot multiple graphs in one figure. Now when we plot a figure in MATLAB, a figure will appear like this, and we can also manipulate the graph by not typing every single command in the command window, but just by using the functions, the edit functions that we have in the figure window. So we can, for example, insert X label here by clicking on insert X label. Then you can type in that X, you can type in the label for X label, for example, like that. Okay, you can also insert the Y label, then you type in sign of X, for example, and it will be automatically adjusted to be in this direction. And you can insert a title, graph of sign X, for example, and then we can also include a legend like this. We have now data, and then we can also rearrange. We can also reposition the legend. Okay, and we can also change the name by double clicking on data 1. Let's say this is Y, for example, and then we put in this is YD, and this is YDD. So that is easier than typing all the commands in here. And also we can, if let's say we want to delete any graph, we can use the tools and click on edit plot. Let's say I want to delete this black line here, so I'm going to click on it and hit delete, so it will also disappear in the legend that we have just created. So that is how we manipulate graph by using the figure window. Next is I'm going to demonstrate another command. So let's clear everything first and create a new script. So here, let's say we want to plot a function. Say we have a function like this. Our function is x squared plus 4 sine 2x minus 1. This is our function, and we want to plot this function. Instead of using the plot command, we can also use fplot. Okay, within a bracket. Now we type in the function in as a string, then we put comma, then we type in the x interval, which is the range. So this has to be written as a vector. So we put in a square bracket. Let's say we want to the minimum value is -3 and the maximum x is 3. So we close the square bracket. Now we put in all the line, we put in the line specifier, for example, and also the property name. So for example, we want it to have a red color with with dashed and also diamond shape marker, and we want to increase line width to 3 and marker size of 15. So we close the round bracket, and when we hit run, the graph will be plotted. Okay, so that is another way to plot a function instead of using the plot command like we have just now. Okay, so now let's take a look at how do we plot special graphics using MATLAB. Let's start with a bar plot. For example, in the script, we have defined a range of years from 1988 until 1994, and we have a data of sales for each year. And now we want to plot a bar plot from this values that we have. So the command is just bar in a bracket year comma sales, and comma R is to change the color of the bar into red color. And then we have the X label and Y label as what we have in the previous plot command. So when we hit run, we will have a bar plot of the sales in millions for every year that we have defined within the range. We can change this vertical bar plot or bar chart into a horizontal bar chart by changing the command of bar into bar H. Bar H, we put a H letter over there, and when we hit run, it will become a horizontal bar plot. Okay, and we also have a command stairs. By using the same values, we can plot a stair plot. This is a stair plot. Looks like stairs. Okay, there is a stair plot. And also MATLAB have also what we call a stem plot. When we hit run, we'll get this kind of plots. Okay, for stem plots for year and sales, this is what will be produced by MATLAB. Also, apart from bar graph, stairs and stem, we can also plot pie chart. Let's say we have a grades of this number 11, 18, 26, 9 and 5, and to plot a pie chart out of these grades, we can just type in the command pie grades, and we can put in title class grades, for example. So when we hit run, we will get a nice pie chart of this values that we have entered, and MATLAB automatically calculates what's the percentage of each values that we have calculated for the pie plot. So another type of plot that we can plot in MATLAB is histogram. Let's say we have this data here. We have 10, 20, 10, 10, 20, and so on. So the largest number is 50. Histogram can plot how many times the number appears. So in this case, the command to type is hist, H-I-S-T, and our variable here is data. So we type in data, and we need to put in what is our maximum value. So here we have 50. So just type in 50, and when we hit run, MATLAB will plot the histogram. So it says that 10 appears 4 times, 20 appears 3 times, 30 appears 3 times, 40 2 times, 50 also twice. So that is the histogram function. And let's now go back to this script over here. So let's say in this case we plot this graph here. Okay, when we hit run, this is what we have. Now let's say we want to create a new figure. We want to have multiple figure window. So in this case, the command that we need to insert is the figure command. So for example, let's say now I don't want to plot everything in one graph. I want to plot them one by one. So I'm gonna plot the first one first. This is the first graph. I want to plot the second graph on the other figure window. So the command that I need to type in is figure, and now I uncomment this. So when I hit run, so you notice that two figure window appears. This represents the first figure. This is for the second figure. So in order to create multiple figure windows, we need to include the figure command here. So we can also say that we can also give a number to this figure. Let's say I want this to be figure 3. So when I hit run, I will see that my first figure is plotted in figure number 1, but my second figure is plotted in figure number 3, simply because I define my figure here to be number 3. Okay. Now let's see how can we plot multiple plots in one figure window. This is called subplot. So this is from our previous example. We have the range of x and 3 functions. So this is the command to plot every single function. So now in order to plot a subplot, the command is subplot. And when we type in subplot, MATLAB requires 3 input. The first one is M, N, and P. So basically, M and N is row by column, and P is the number of the plot. So in this case, we have 3 plots to plot, and we want to plot it from up to down. So basically, we're going to have 3 rows, and we just have 1 column, and this will be plot number 1. So we type in 3, 1, 1, 3 for the 3 rows, 1 column, and plot number 1. So we close it, and then the command is down here, and we do the same for the next subplot. Now 3 rows, 1 column, plot number 2, and for here subplot 3 rows, 1 column, plot number 3. So when we hit run, we will get 3 by 1, 3 rows by 1 column plot that contains every single plot like we have here. So that is how you plot a subplot using the subplot command.